Alright, so let's see if we can find the max and min of f of x and y is 5x minus 3y, where x squared plus y squared is 136. How would I start this?
Find the gradient of the r
Yeah,
squared.
Okay, so gradient of, I don't know, what's the x squared plus y squared? What do you call that?
Let's say R.
R. That's really the r squared function, right? Which I
Yeah.
think is what Jacob. Okay, so what do you get? 2x and 2y. Okay, this is a little bit boring. How about the gradient of f? What do you get? 5 and negative 3. Okay, so then what do I do?
With the line.
Okay, so I need gradient of r is gradient of f times some constant lambda, right? Okay, so that's going to give me how many equations here? Two?
Yeah.
One for the x derivatives and one for the y derivatives. So I'm going to get
2x equals 5 lambda.
2x is 5 lambda and
2y is
2y is negative 3 lambda. Okay. Now you have 2 variables and 3 unknowns, right? Did you all see that? Okay. Am I totally hosed or what? Okay.
Just get x and y by itself.
No. Negative. Get lambda by itself. Why would you get lambda by itself?
That's
Yeah,
what it's-
because I don't care what lambda is, right?
Okay.
So I'm going to try to get rid of it as soon as I possibly can. So,
You can add those equations.
Oh yeah, because if you get them in terms of lambda, you just equal each other.
Yeah.
yeah, if I can get both of them equal to lambda, then I can just equate the two equations and then I'll be kind of okay, right? Alright, so let's see. That reads like I've got 2/5 x is lambda, right? And lambda is also negative 2/3 y. Good. Okay, so that reads as 2/5 x is negative 2/3 y. Why does this feel like I don't have enough information?
You haven't used the 136 anymore?
Yeah, I haven't used the constraint yet. You guys see that? Okay, so how do I use that?
Subtract.
For one variable and plug it into a constraint.
Okay, so which variable?
X.
X? Okay, so x is what?
10 over 6.
Negative 5/3 y. Okay, then you take this information and go where with it?
Plug it back into one above it.
Into this one?
Plug it
If
into
you plug
our
it into this one, you'll get
Yeah,
x is
yeah,
x.
Into the x
Right,
squared
because
plus
these
y
two
squared.
equations contain the same information, right?
X squared plus y
Put it
squared.
into
Yeah.
your constraint.
Yeah.
Yeah, that should go in my constraint. So I've got x squared, wait. I've got what?
Negative 5/3 y
Yeah.
squared.
Negative 5/3 y squared plus y squared is 136. Okay, so then what?
5 over
25 ninths y squared plus y squared is 136.
Negative.
9. 34 over 9.
34 y squared over 9 is 136. Yuck. Calculator time?
Yeah.
Y is, I'll put in the plus or minus for you.
Donald's on it.
Plus or minus the square root of 136 times 9. Plus or minus 6.
That's what I was waiting for. I knew I orchestrated these numbers well, but I should have made them smaller. Okay, so I got y is plus or minus 6, so what do I do with that information?
Plug it back. Yeah, plug it back.
So x is plus or minus
10.
10.
Okay. Okay. Cool. That gives me 4 things, right?
It only gives you 2.
Does it?
Because the plus 6 corresponds to the negative 10.
Does it?
Well, it doesn't matter because they're being squared.
Well, in our
Where am I looking to see if they correspond?
The f of x, y.
Yeah, let's see. So I seem to have 4 things, right? But do all 4 things satisfy this guy?
no. That's
Right? All 4 things satisfy my constraint, right? But there's only 2 points here. You guys see that? That satisfy this equation. So those go as, what are your pairs?
6
6
negative 10.
and negative 10?
Well,
Or,
flip-flop on -10 and 6.
yeah, negative 10 and 6.
Oh. Out of that
Wait.
the first time.
That's
No,
what
no,
I'm saying. That, yeah.
No,
I
and
went
then
y
do-
I
and then
flipped
do
these
10
two,
and
didn't
6.
I?
10 negative 6.
10 and negative 6.
I went in the order that we.
Or
had them.
negative 10 and 6. That's cool.
Why is it like that?
But I know they have to have opposite signs because this thing says
6
they have
times
opposite
-5 is
signs.
Okay.
Right, so it's not just the constraint thing you're dealing with, right? It's also the Lagrange multipliers piece. But you need both pieces, right? You're gonna need to use the constraint a little bit, and you're gonna need to use the Lagrange multipliers piece a little bit. Cool? So,
Max or min.
which one's which?
Now we plug them into our.
Yeah, you can just plug them in and figure out which one's higher, right?
10 and negative 6 would be.
So 10 and negative 6 gives me something positive, right? And negative 10 and 6 gives me something negative.
Yeah.
So there's your max, and here's your min.
Okay.
And of course, writing a little sentence would be nice, right? So if we were going to write a good sentence for this, how would we write it?
The maximum of f of xy equals 5x minus 3y. Where x squared, you just pretty much rewrite the question
Yeah.
that we wanted to do on the test.
Yeah.
And write it nicely.
Yeah, I think you should answer a word problem like a person, right? If you don't get used to doing this, your boss at an engineering firm is going to be like, seriously?
Yeah.
Like you have to write a report that
Yeah.
says what you got, how you got there, and what it means. So this is the simple, like, there's your how you got. This is the what you got and how does it, like, what does it mean?
Yeah.
Okay. So the maximum of f, where constraint is what?
10 negative, or
Just distance from the organs.
10, negative 6, right? And maybe you should put in the value too, right? So
32?
X is 10.
I'd say is above, right? The max value is what?
32? Oh. Oh, minus,
68.
minus.
Right? And then the minimum is above, below, whatever, right? Negative 10, 6. And the value is negative 68. Cool? It doesn't have to be like the best sentence ever, right? But it should have like the right words. Cool. And I would like you guys to differentiate between a point in the domain and the value associated to that point, right? So these two, the 10 and negative 6 and negative 10 and 6, those are points in the domain. The value is an output, right? The reason I'd like you to get that distinction now is that there are sometimes units associated to these, right? And I would like you to know which units go with what. Cool?
Do you know what it would look like three-dimensionally off the top of your head?
This thing?
Yeah.
Yeah, absolutely. This is that first set of level curves I was drawing. So this thing's a circle,
Okay.
and that thing's a plane. So I've got a right there's ellipsoid in 3 space that you make out of taking a circle and putting it on a plane. And then I've got the low point and the high point. And it happens that this plane is kind of at 0, 0.
So have you like your
Right.
circle of inputs is your
Yeah. Yeah, I've got a circle in the domain that I'm restricting to. And then I've got the outputs associated, which are the heights.